Sí, gracias.
Gracias.
Adelante.
Muy bien. Bueno, pues muchas gracias a todos por conectarse. El día de hoy tenemos el gusto de tener a Mariana Laverde de Boston College. Bienvenida, Mariana. Qué gusto que hayas aceptado nuestra invitación. Quien nos va a presentar su paper Distance to School, Schools and Equal Access in Schools Choice System. Tienes aproximadamente 90 minutos y se hacen preguntas, como te dije, durante la presentación y si queda tiempo un poco al final también.
Perfecto.
Bienvenida.
Muchas gracias,
Adelante.
Laura. Muchas gracias por la invitación. Estoy muy contenta de estar acá. Ojalá en alguna próxima ocasión en vivo y en directo, como le decía a Edwin, para comerse unos buenos tacos. Pero en todo caso, muy contenta de estar acá. Muchas gracias a Edwin y a Laura y a todos por la invitación. La presentación la voy a hacer primordialmente en inglés, porque así están las slides y todo, pero podemos hacer un poquito de Spanglish. Sí, es necesario. Seguramente alguna otra cosa saldrá medio en español. Entonces va a cambiar de idioma. Muchas gracias a todos por estar acá. So today I'm going to be talking about distance to schools and equal access in school choice systems. By ways of motivation, let me start by saying that, well, since the late 1980s, many cities in the United States and abroad have implemented school choice systems. These systems, or with these systems, parents have the opportunity to express their preferences to school authorities, and school authorities use these as inputs to generate assignments of students to schools. And this is in contrast to more traditional neighborhood assignment rules, where students are assigned to the schools that are closest to their homes. One of the reasons why choice systems have gained traction is precisely because by decoupling residences and schools, choice systems have the potential to both reduce school segregation and equalize access into high quality education. And the logic here is very simple. Instead of assigning everyone or every student to the school that is closest to their homes, the system allows families to apply with fair chances of admission to the best schools across the city, even if these schools are far away from the homes of the students. Now, despite this, when we look into the data from Boston, which is the setting I will be studying, we see differences in the types of assignments of Black, white, and Hispanic students in Boston. So here I'm showing you in this graph to the left, I'm showing you the cumulative distribution of school achievement at the schools assigned to Black, white, and Hispanic pre-kindergartners. The measure of school achievement in the x-axis is the fraction of third grade students in each school that score above a threshold in a state math test. This means that higher values of this measure indicate that a school is higher achieving, and what this graph is showing us is that along the distribution, for each percentile of the distribution, white students are assigned to schools that are higher achieving. So we see a clear dominance across these distributions. And of course, if this is true for every percentile, this is also true for the mean. So the average white student is assigned to a school that is higher achieving relative to the average Black and Hispanic student. And here the means of these distributions are depicted by the vertical lines. So this very clearly shows the gap in access to high quality or high achieving schools better among these races. And just to have a benchmark, I'm going to take also this data. Again, these are the actual assignments generated by Boston Public Schools. And I'm going to ask myself, well, what would happen if I took these very same students and I reassigned them to the schools that are closest to their homes? So this didn't happen in reality. I'm just going to take the data, I'm going to play with it, and I'm going to say, well, what would happen if I reassign students to the school that's closest? This would be kind of approximating a neighborhood assignment, and I want to see how would this graph look like in that case. And when I do that, I find that actually things don't look that different. So it is still true that white students are assigned to schools that are higher achieving, both on average, and it is also true for every percentile across the distribution. And this is the main fact that this paper wants to investigate, namely, why is it that under choice systems, we see a gap in access to high achieving schools that hasn't shrunk to zero? Why do we see differences in access to high achieving schools, even under a choice system that allows families in principle to sort into the schools that they find more desirable?
Oye, Mariana, y de hecho, soy Laura, hola, y de hecho, como que en tu gráfica, digo, además de que se ve que los patrones son muy similares, como que solo beneficia, bueno, pareciera que beneficia lo del school choice, pues principalmente a los blancos, ¿verdad? Porque en la de la izquierda tienen una media un poquito, ¿no? No mucho, pero un poquito más alta que en la derecha, ¿o no? Mientras que los de Black y Hispanic sí se ven pues casi idénticos prácticamente.
Cierto. Sí, cuando uno mira los datos en detalle, efectivamente pareciera que la ganancia marginal es más grande para los white. Con un caveat, y por supuesto es que el ejercicio que está en mano derecha es una aproximación, en el sentido en que si yo implementara un neighborhood assignment, probablemente la gente tomaría decisiones de housing diferentes a las que toma y pasarían otras cosas en equilibrio general que yo no estoy pudiendo capturar. Entonces, yo creo que hacer un statement de que school choice es peor que neighborhood es un poco fuerte. No, eso no es, digamos, lo que yo concluiría, pero ciertamente sí es diciente que al menos este ejercicio, que de nuevo no deja que se hagan estos ajustes de equilibrio general, sí se ve un poco eso que tú dices, sí.
Gracias.
Un gusto.
Oye, Mariana, una pregunta. Bueno, más bien una idea que comes to my mind. Is there some self-selection to the left?
What you mean? Within races?
Yes.
I think that yeah, for sure. So if this is what you mean, so let me explain myself, and maybe this is not what you have in mind, but when we see to the white student population that is in Boston public schools, that's very different from the white student population in Boston. While I think that the white student population in Boston is close to 50 or 40 something of the population, about that, we see that the white student population in BPS is about more like 23-25%. So there's definitely, if that is the subselection you're talking about, yeah, for sure. There's probably an overrepresentation of Black and Hispanic in this sample and an underrepresentation of whites as relative to the overall population. What does this mean? That probably a ton of these white students go out of the public school district. This may mean parochial schools. This may mean private schools. And perhaps even if we took those into account, the gap would be larger. I'm not sure. I do not have that data. There are reasons to believe that that would be true. But I don't know. Nevertheless, even within the public school sector, we see this fact. So yeah. So yeah, there's definitely some selection. Okay, great questions. So let me keep on going. So as I was saying, what this paper is trying to do is I want to investigate the reasons why the effects of choice are limited. Concretely, why is it that choice systems do not equalize access into high achieving schools? And in order to do this, I want to quantify the contribution of 3 mechanisms to the cross-race gap. The gap is basically that distance that I was just talking about. That's what I mean by the cross-race gap. I want to quantify how much each of these 3 mechanisms that I'm going to explain in a minute contribute to that gap between white students and Black students and between white students and Hispanic students. And the 3 mechanisms that I want to study are the following. First, I want to start by thinking, well, how much of this gap can be explained by differences in demand, basically in parental demand for schools. But importantly here, I want to distinguish between 2 things. The first thing is differences in demand that are stemming from differences in distance to high achieving schools. So most, if not all of the literature that have studied parental demand for schools coincides in finding that distance is really salient and relevant for parents where they're making choices about schools. So if it is the case that a population Black, Hispanic, or other population tends to live farther from schools that are higher achieving, even if they value those schools just as other populations would. Just the distance component would mean that they would have a lower demand for them. So that's part one, understanding how much of this is demand driven, but explained via distances. The second is, well, this could also be explained by differences in demand that stem from any other school characteristic that's really not associated with distance, but any other thing. And that's basically explanation number two. I want to understand how much of the gap is explained by differences in preferences for schools for what I call non-location or location-independent school attributes, anything else that's not related with distance. And finally, I want to understand how much of this gap can be explained by some assignment rules of the algorithm. And I'm going to be very explicit in a minute explaining exactly what rules I refer to, but there are going to be some rules that I think I'm going to argue, have the potential to explain part of this gap. Now, how am I going to do this? Well, the first thing I'm going to do is I'm going to use rich data on parental rank choices submitted to Boston Public Schools to estimate a model of school demand. This model will allow me to do first to disentangle parental preferences for proximity, so a term that's going to tell me how costly it is for parents to travel farther. And I'm going to disentangle that from what I call the location-independent valuation of a school. So basically the value that families place on a school once we have kind of subtracted, if you want, the effect of distance. So the value placed on the school, ceteris paribus of distance, if you want. And importantly, this model is also going to allow me to capture some heterogeneity in preferences, both by race and income, that is going to be crucial for later on. What am I going to do with the parameters of the model? In a second step, I'm going to take these parameters and I'm going to use these parameters to generate a series of counterfactual assignments that are going to help me quantify the contribution of those three mechanisms that I mentioned earlier. So to be very concrete, basically what I'm going to do is I'm going to be thinking of three types of counterfactuals. The first one is I'm going to be thinking what would happen with the assignments and of course the rankings of families if families change residential locations. So the thought experiment here is imagine a minority family, let's say a Black or a Hispanic family that moves to a new location. If this family moved to a location that looks much more like an average white family location, how would the assignments and the rankings and the assignments look like? Second, I want to think, okay, what would happen if instead of thinking of a change in the residential location, we instead thought of changing the demand parameters of families, let's say those of minority families for those of white families, and try to capture how much of the gap is explained by those preferences. And finally, I'm going to be changing some assignment rules in the algorithm, and I want to try and explain how much those rules impact the ultimate assignment that we observe. And I'm going to do this using applications to pre-kindergarten in Boston Public Schools using data from 2010 to 2013.
Mariana, soy Yolanda, ¿te puedo hacer una pregunta?
Por supuesto.
Y me está preguntando que sobre todo estos factores, los parámetros de la demanda de los padres, me llamaría mucho la atención qué pasa con las minorías asiáticas. Pues está todo no sé qué tanto cliché o qué, pero que la selección educativa tiene un componente muy importante y imagino que no sé si por minoría igual no es tan importante o porque me llamaría la atención su comportamiento en este escenario.
Bueno, desafortunadamente no va a tener mucho que decir del grupo de las familias asiáticas. En un minuto te va a mostrar cuál es la descomposición racial de los aplicantes. Y el grupo de los que se seleccionan o reportan como ser pertenecientes o que se seleccionan como de raza asiática o en el grupo étnico asiático, son muy chicos. Entonces okay. Es más o menos el 7-8% de mi muestra. Entonces realmente yo no voy a estimar preferencias para ellos. Y ya, en un minuto voy a explicar exactamente cómo lo voy a hacer. Solamente voy a estimar preferencias para Black, White y Hispanic, que es los grupos en los que me concentro. Sin embargo, o sea, voy a mostrar algo de estadísticas al respecto y podemos hablar un poco más en ese momento si quieres. pero igual uno ve cosas interesantes. No sé exactamente qué pregunta tenías en la cabeza, pero ciertamente hay cosas.
Me preguntaba que tal vez las familias asiáticas, si aceptáramos, no sé si el cliché o el elemento cultural de que dan una mayor importancia a la educación, pues
Sí.
podrían tener un comportamiento de demanda diferencial y tal vez en términos de minoría, pues tenga un comportamiento distinto, que no sé si pudiera dar luz un poco a esto, pero imagino si son también imaginaba que podrían ser muchos menos que los hispánicos o los negros.
Entiendo. Probablemente sí habría una heterogeneidad. Sí, desafortunadamente no, acá no puedo hablar mucho de la heterogeneidad específicamente de los asiáticos. No en este paper al menos. Pero cuando hablemos más de preferencias te puedo mostrar lo que tengo, sin lugar a dudas. Gracias. Perfecto. So to give you a preview of the findings, basically I find that the first mechanism, which is demand-driven explanations that are explained through distance, explains the majority of the gap. So it's the most important or the most salient mechanism. It explains about 50% of the gap. So put in other words, had Black students or Hispanic students lived in locations that look more like white students' locations, the gap in access to high achieving schools would be reduced by half. I do find, though, that valuation for non-locational school attributes, anything else that drives preference heterogeneity that is not captured by distance, also explains an important part of the gap. For Black students, it's about 40% of the gap. For Hispanic students, it's about 30% of the gap. So still very important shares, although less than distance again. And finally, and interestingly, the rules of the algorithm do not have any effect. And again, I'm going to be more specific about those in a minute. But it's important to mention that I don't find that any design-based part of this has any impact on the gap itself.
Oye, Mariana, y el non-location es como que todo lo demás, ¿verdad? No identificas adentro de eso nada en particular. Es simplemente todas las otras características como que as a whole explican ese porcentaje, ¿correcto?
Correcto. Yo hago un pequeño, eso es más descriptivo que cualquier otra cosa, pero sí. Uno puede después tomar esos deltas, mi modelo se va a llamar deltas, pero uno puede tomar esos parámetros, digamos, del valor de cada colegio, una vez descontado la distancia, etcétera, y uno puede tratar de preguntarse eso está correlacionado con qué. Entonces uno puede hacer una regresión lineal, digamos, mapear eso a características de colegio. Y uno encuentra que está correlacionado en las dimensiones que uno se imaginaría, de eso hablar en un minuto. Sin embargo, no cuantifico el impacto de alguna característica en particular sobre en última, sobre el gap. Yo creo que, o sea, la razón por la que no lo hago no es porque no crea que sea interesante, sino porque creo que cualquier afirmación sería un poquito atrevida en el sentido en que tendría que justificar alguna variación exógena en esa característica. Y creo que sería complicado pensar en eso. Pero podemos hablar un poco más de nuevo cuando te muestre los resultados.
Gracias.
Creo que sería difícil.
Sí, gracias.
Perfecto. So in terms of the review of the literature and where this paper contributes.
Sorry, Mariana, would you mind explaining again the mechanism for the first effect? How does distance affect demand for school?
Sure. So I think this is going to be more clear once I show you a little bit more about the model. But basically, the thought experiment is the following. I mean, let's first think about demand explanation. So the gap could be explained because people just value things differently, right? Because maybe white parents, Black families, and Hispanic families just value things differently. So that just explains the whole thing. But that seems a little bit simplistic, right? So we would ideally want to understand, well, from that demand side, how much is explained by the fact that distance is costly for everyone. So traveling to a school that's farther is costly for everyone. We think that that's true, and I'm going to show you that that's true. But if some people tend to live farther from those schools that are higher achieving, so maybe there are some families that would have demanded that school or ranked that school in the first choice, let's say, But given that they live far away, they do not do it. So it is demand driven, but it's not driven by preferences really, but also because there's kind of more like a constraint thing there, like there's a cost of accessing those things. So that's why I want to separate these two things, because the first one is clearly something that seems more policy relevant than the second one. So yeah, that's basically it. Cool. So as I was saying, in terms of the review of the literature, I think this paper contributes, and I'm going to try to go relatively fast through this, but this paper contributes, I think, mainly to three strands of the literature. The first one is the papers that have talked about the effectiveness of school choice, generating system-wide improvements in quality. And here, there's been a lot of work from the proponents of choice that have expressed that having school choice, is good for generating system-wide improvements in quality because there's going to be demand pressures from families, et cetera, et cetera. I think the latest paper in this literature is Abdul Khalil 2020, that the latest, I mean, not taking into account this one, of course, but Abdul Khalil 2020 that says, you know what, from our estimates, they conclude that parents don't really value school effectiveness, they value more peer composition. So then if families don't really value effectiveness, well, we shouldn't expect to see system-wide improvements in quality. So there's been like a whole debate about this. What I think this paper contributes to this literature is by saying, look, even if parents value somewhat effectiveness, even because perhaps effectiveness is correlated with we know effectiveness is correlated with peer composition. So even if they valued somehow effectiveness because they value peer composition, so just by means of correlation, again, distance can be important enough to ameliorate those demand pressures. So the same thing that I was just answering Edwin. So maybe I do value that school that's far away and it's really great and I would really want my child to be there, but it's just too far away. So I'm just not gonna rank it. So again, whatever demand pressure I was gonna put on the schools around me, it's gonna just be ameliorated by the fact that distance can be really costly. So that's I think the first part. And then for the second one, this is, I guess, more of a humble contribution, but this paper kind of highlights the fact that the provision of public goods really sometimes can happen really at a very local level. So families react very harshly to distance. It is important. So in these papers that talk about neighborhood effects and the impact of growing in a specific location on future outcomes, these papers have mainly found a lot of very granular differences. So one county or one tract that's very close to another, we can see very stark differences in intergenerational mobility, for instance. And I guess that what my paper is saying is, you know what, families really react to distance in a way that's salient. And that could actually explain a little bit that granularity in those measures. So access to public goods basically is going to be pretty much driven also by those distances. And finally, this paper contributes to a set of papers that have used rankings data from school choice systems to study both the properties of the algorithm and parental demand for schools. And that would be a third one. But let me again skip that. This would be the outline of the rest of the talk. So I'm going to first start with a little bit more of details about the setting and some descriptive evidence of the mechanisms. And I'm going to then jump to talk about the model of school demand and the estimates. And finally, the counterfactual analysis and the conclusions. So let me start by talking about, well, how's the assignment process work? How does the assignment process work in Boston? So it mainly has three components. The first one is parental preferences, as I already talked about. And mainly in Boston, families are asked to submit a ranking. So if I want to apply for a seat in Boston Public Schools, I, as a parent, need to submit a ranking of the schools that I want my child to be. Families are prompted to rank schools in preference order. So not only the algorithm is strategy proof, and I'm going to talk about that in a minute. So not only parents is in their best interest to be truthful, but also the system kind of reminds them that it's in their best interest to be truthful. Importantly, this is not something that's too common, but it happens in Boston, there are no restrictions on the length of the list that parents can submit. So they can submit as many choices as they can, as they want. But despite there are no restrictions in the length of the list that the parents can submit, there are some restrictions on eligibility, geographic restrictions on eligibility. What does this mean? That not everyone can rank every school. There are going to be some schools that a specific student cannot apply to. And I'm going to discuss those restrictions in a second. So that's on the side of parents' preferences. Now, on the side of school priorities, students are mainly prioritized by two criteria. So students that have a sibling at a specific school have a higher priority at that school, and students who live within a mile of a school, what in Boston is called the proximity priority, are prioritized over students that live farther away. And finally, the assignment is generating using both the preferences, the priorities, and the capacities, and using the student proposing the fair acceptance algorithm that, as I mentioned, is strategy proof, which means that truth telling is a weak dominant strategy. This is going to be important because, of course, we're going to rely on those rankings to learn about preferences. So these rankings should be really revealing preferences and not something else.
And we believe that because there is kind of evidence. Recently, there are like some papers showing that despite people, the mechanism being strategy proof, people do not behave as they are supposed to do in a strategy proof mechanism. So
true, no, true. It's a good, those are good points. So I think that there are several dimensions in which one could be concerned. So the first one is, well, there's papers that have shown that if there are restrictions to the lists, that can be problematic. We do not have those, so we say, okay, that's good. There's papers that say, you know what, if families can, or if people can anticipate their chances of admission very well, if they can forecast those very well, they may be skipping some schools that they think they do not have any chance. Or if they think that they will for sure get into some school, they may skip ranking anything else or something like that. What I find is that in my setting, at least, it is not true that, I mean, so let me say this first. It is hard for anyone to really forecast the probability, in the sense that even though I may know my priorities in terms of whether I have a sibling or where I live in the walk zone, there's on top of that like a random number, which I would never know. And moreover, when I look into past data and see whether there are schools that never accept someone without a priority, for instance. So parents that didn't have any priorities, nor sibling nor walk zone, would of course say, okay, I don't have a chance because in the past 10 years, they haven't accepted anyone without a priority. Even if they knew all of these things and could do that, perhaps they could try to figure out these things. But what I find is that that doesn't really happen. So what I mean is there's no schools that have never accepted, or there are, I think, only 2 programs, so among all the things that I studied, that have never accepted people without a priority, for instance. So those probabilities are not zero, mainly. There's really not a combination of student schools where the probability of being accepted is really, really zero. So that also ameliorates some of those concerns. So I think that most of the concerns can be reasonably rolled out. I'm not too concerned about the strategy proofness not being satisfied here overall. Cool. Okay. Thank you for the question. So let me, as I was saying, I mentioned before that there are some geographic restrictions on the choice menu. So let me just talk about that for a minute. So here I'm showing you a map of Boston. In my study period, Boston was divided into 3 zones: the north, the west, and the east zone. And here the triangles are all of the schools that had a pre-kindergarten program in 2010. So basically that's where the schools are located. And the rule says that a student can rank any school within their zone of residence, plus any school that is within a mile of their homes. So to give an example, a student that lived here, very close to the frontier with the West, but that lived in the East zone, would be able to apply to any school here in the East zone, plus the school here in the West, because that's kind of closer than a mile. A mile looks kind of like this. A mile around that triangle would be something like that. So that kind of defines what sort of schools can a student apply to. So within that set, students can rank any number, but there's some restrictions in which schools they could rank. So this is a good moment to tell you about two rules of the algorithm that I'm going to argue have the potential to contribute to this gap. And the rules are, first, choice menu restrictions. So this one here, the fact that there are some families that cannot choose some schools. So if, say, white families have in their choice menus a higher fraction of seats that are higher achieving, then just mechanically some of this gap may be generated by that. So that's the first rule I want to study. The second rule is proximity priorities. And I told you that students that live within a mile of a school have a higher priority of assignment. So again, if it is the case, and I'm going to show you that this is true, that white students tend to live closer to schools that are higher achieving, then just by means of the priority, they have a higher chance of getting accepted into those schools, even if the preferences, two different parents submitted are exactly the same. Well, the white family that lives closest to the school is going to have a higher chance of admission. So when I talk throughout the talk, when I'm going to be talking about the rules of the algorithm that contribute or not to the gap, I mean these two rules concretely: the fact that there are restrictions on choice menus and the fact that there are priorities determined by distance to schools. Great. So in terms of data, I'm going to use, as I said, data on applicants to BPS. These are first round applicants to pre-kindergarten between 2010 and 2013. I have basically all of the profile for these students, what they ranked, where do they live, some of their characteristics, what did they get assigned. I know information about the schools in terms of their location and the capacities. With this information, I can get linear distance and walking distance and walk times between every student and school pair. And finally, I have information from the Massachusetts Department of Education on a wealth of school characteristics, including school achievement and some school demographic characteristics. To give you a sense of my data, I have about 9,000 students. As I was saying, a bunch of them are Hispanic, so about 43% of students in my sample are Hispanic, while Black and white are about 23% of the sample. And as I was saying, when you go and look into the demographics of Boston, it's more like whites are more like 40 something. So that's where we see that selection that we were talking earlier about. Also, as I mentioned, the Asian population is small, so 8%. So I won't really estimate preferences for Asian students or other minorities, and I will just concentrate on these three groups here. More information in terms of the size of the choice menu. These families have about 25 schools to choose from. The choice menus are a little bit larger for Black students and a little bit smaller for white students. In terms of, sorry, I skipped this one. In terms of the length of the list that the parents submit, it's on average of size 5. So parents on average submit a ranking of 5 schools, with Black students submitting a slightly larger list and white students submitting a slightly shorter list. In terms of the school that these families get assigned to, it's typically the school rank on average in the 1.8 position, so about the second school in the ranking. And when we look into the distance to the assigned school, these families are on average assigned to schools that are 1.2 miles from their home, with the distance being a little bit shorter for white students. Now, where are students located in space? So here again, I have a plot of Boston and kind of a spatial distribution of my sample. Each of these dots represents about a dozen students. So what we see is, well, yes, there's some segregation indeed. So we see that Hispanic students are concentrated in the north part of the city, although you really see them scattered a little bit everywhere, although there's a big cluster without a doubt in the north. We see that Black students are more on the east of the city, Although again, we do see them a little bit everywhere, perhaps with the exception of this corner of the city. And then for white students, we see them kind of in the opposite side of where Black students are. But again, you see them, some of them scattered along the city. And finally, in terms of schools, so again, in my data for all the years of my data, I have 67 distinct schools that sum to a total of 258 observations. So I do not see every school in every year. There's some schools that come and go. The average capacity of one of these pre-kindergarten programs is about 30 students. And in terms of school characteristics, they're very heterogeneous. And I think that that's kind of key for understanding these differences. So in terms of school achievement, when we think about the achievement of these schools, on average, there's about 46 students that score advanced or proficient in math. These are third grade students, but this can be as low as 2% for some schools and as high as 90% for others. So huge heterogeneity in achievement. And when we look into demographics, again, we see that the average school has about 32% of Black students, but it can be as low as 2% for some schools and as high as 80% for others. In terms of low income students, we see that on average, this is a district that is on the poorer side. So the average kindergarten class has about 70% of students that are classified as low income. Again, there's heterogeneity with there's schools that have as low as 8% of low income students and schools that have as much as 100% of low income students. So this heterogeneity is salient again, well, because if all the schools were pretty similar, well, we don't really care that much about what's really happening, but the salience of this heterogeneity is really highlighting the importance of this.
Oye, Mariana, una pregunta, ¿y qué información, disculpa si ya lo dijiste, qué información sobre School Quality está disponible para los padres a la hora de hacer su decisión, de tomar su decisión?
No lo he dicho, es una buena pregunta. Los padres, cambia un poco en el tiempo, pero los padres reciben como un booklet, en esa época físico, donde tenían toda esta información, digamos. Hay una información que no está en esos booklets, pero esta que es como una información muy agregada, toda está. Entonces,
fácil de entender, digamos, es agregada y fácil de comprender, más o menos, ¿no?
Es fácil de, o sea, probablemente se parece a esto. Es fácil de comprender en el sentido en que son estadísticas de este tipo. Yo imagino que para algunos padres igual entender si 46% high achieving es alto o bajo, no sé qué tan fácil es de comprender, pero sin embargo es suficiente para que ellos hagan comparaciones entre colegios, eso seguramente, seguro sí.
¿Y les reportan el porcentaje por raza también, sabes?
Tengo entendido que sí, por lo menos, no sé si todos los años, pero sí, por lo menos varios años, ese es el tipo de información que está ahí. Hay otra información que es más difícil de encontrar en esos booklets, como medidas de value added.
Claro.
Creo que son más recientes, tal vez en los años más recientes sí se hace, pero no necesariamente en todos los años. Pero estas cosas que son más agregadas, más, digamos, fáciles de consumir, sí están ahí, por lo general. Sí.
Muy bien, gracias.
Un gusto. Perfecto. So let's go back for a minute to where we started. So we started saying that there's a gap in the average school achievement at the schools where these students are assigned to. So here I'm plotting precisely the means of the distributions that I showed you at the very beginning. So this is not new. We already knew these white students are assigned to schools that have on average higher school achievement. Now, just to have a sense of what's happening here, I'm going to show you the average school achievement for different subsets of schools. So let's start with choice menus. We said that if the choice menus of different types of families looked very similar, perhaps some of the gap can be explained by that. Well, when I take the choice menus of Black, Hispanics, and white families, and I compute the average school achievement at those choice menus, we actually don't see much difference, just a tiny bit, but still it's not very salient, especially when we compare it with the huge gap in assignments. So it seems like a lot of the action is not going to be coming from differences in choice menus. Now, what about the walk zone? So the 1 mile radius around the home of every parent. we know that families have a priority over those schools that are very close to their homes. So let's see what happens if we zoom in into those schools in a mile around the home. How does this look like? And well, what we find is that indeed there's a higher gap now that is relative to the choice menus. So this means that within the mile of residence of these families, white families find schools that are higher achieving, and this means two things. First, that they will have a higher priority at those schools than Black and Hispanic. So they have priorities at schools that are higher achieving. So proximity priorities are schools that are higher achieving. But we think that this teases out or kind of suggests that white families also tend to live closer to schools that are higher achieving. And we know that that may matter not only via the priorities, but it may matter also via the demand. So to just have a sense about the difference in demand of these families, here I'm plotting the average school achievement at the first choice schools of these families. So whatever they ranked as their first choice. And what I find is that now the gap is larger and actually looks very similar to the gap in assignments. So basically what this is showing us is that, well, it seems like a lot of the action is not going to be coming from choice menus. Perhaps some may come via the proximity priorities, but it seems like demand is really going to matter here, which is very much in line with the preview of the results I already showed. And just to be more emphatic about this distance story, here I'm plotting you in the x-axis, the quintiles of school achievement. So I have buckets of schools, and in the y-axis, the average distance between those schools and Black, Hispanic, or white students. And two things I want to highlight. The first one is that if we look at those highest achieving schools, white students are closer to those than Black or Hispanic families are. It's also true here, but I guess not super salient. But I guess the thing that I find more striking is that while this graph shows us that while white families do not trade off distance and achievement, minority families do. This is very clear, especially for Black families. So what do I mean by that? I mean, well, if a family, on average, a Black family wanted to go to the school that's higher achieving, they have to travel farther. So they have to trade off achievement with distance. That is not true for white families who actually, on average, if they wanted to go to the school that's that's highest achieving, then they actually need to go closest to their residences. So that just kind of, I think, very emphatically shows this difference and how this cost really matters and is different across these sets of families. Great. So since there's only so much one can do with simple statistics and we're looking at data, the next step is to write a model that lets us analyze the preferences of families for schools. So basically, what I'm going to write a group-specific random utility model. Basically, by group-specific, I mean I'm going to estimate this model by clusters. So I'm going to estimate this model by cluster that are going to be defined as the intersection of a student's race and income. So to be very concrete, I'm going to have 6 clusters in total, one for each race, Black, white, Hispanic, and in those races, I have income below median and income above median. So that would give us the 6 clusters. So again, this allows us to have some heterogeneity in preference, both by race and income. And the group-specific random utility model is going to depend, of course, on the distance. So dij is the distance between student I's residence and school J. And we're going to have, of course, a parameter that's going to be cluster-specific again. Lij is it's basically it's a dummy variable that's going to help us capture instances where a school has a language program that is, say, in Spanish, and well, that should be especially valued by Spanish speakers. So the Boston population has a ton of students that are not native English speakers, or at least that in their household, they speak another language that's not English. This is true for Cape Verdeans, who are a big population in Boston. This is true, of course, for some Hispanics. So basically, we want to capture the fact that some families will value having their kids in a school that speaks their household language. And finally, this term delta CJ is what I was referring by earlier by the location independent school valuations. So delta CJ, the best way to think about it is some sort of school fixed effect. So it's going to embed all of the school amenities and disamenities, everything in one parameter. Once we have kind of subtracted the effect of distance. So this would be the location independent valuation for school J for families in cluster C. And I'm going to be assuming epsilon ij is, of course, going to be idiosyncratic shock, preference shock, and I'm going to be assuming that epsilon ij is distributed type 1 EV, which is going to give us a logic structure to this model.
Question, in this specification of preferences for schools, where the composition of the peers enter in the preferences is the delta?
Exactly.
Because I think that can be correlated with D, right? No?
So it can be correlated with D. It could.
Okay.
But whatever peer composition, and by peer composition, I guess you mean the racial composition.
Yeah, of course. Yes.
Okay. So let's say the racial composition of a specific school, whatever that, so after discounting the effect of distance, because it may be correlated, but we're gonna, everything that's correlated with distance is gonna go to beta. The rest is all going to be captured by delta. Okay.
If I prefer to go to schools where there are more Hispanic people because I feel comfortable with Hispanic people, then that's going to be captured by beta, right?
By beta?
Because in the map, okay, maybe I'm not understanding something, because in the map, the composition of the school is not correlated with the distance.
So in the map I showed you where people live, right?
Yes.
And it is true that, let's say in the north,
yes,
a lot of Hispanic students living.
Yeah, but I am assuming that there are also a lot of Hispanic.
No, but I think you're right in the sense that most likely, if parents value distance, most likely those schools will have a lot of Hispanic students. And if families also value being with Hispanic students, that will also somehow be reflected, right? The point is, unless those two things are collinear, which I don't think they are, that would be very surprising, right? Beta should be only capturing the effect of distance, really. While the fact that a school has more Hispanic students than I value Hispanic students should be captured here. Because imagine that maybe the school closest to my house has a bunch of Hispanic students. Yeah, I would have an identification issue there, but maybe the next one also has a lot, but maybe the next one doesn't, and then the next one has. So the fact that these things are not collinear, that's where the identification of the delta is really going to come from. The fact that you really prefer more Hispanic or less Hispanic is going to be explained by that. And the fact that you prefer closer to farther without any respect of the peer composition would be captured by beta or something like that. That makes sense? So yes, so I guess that goes back to Laura's question as well. I'm not really gonna break this delta. There's a ton of things in delta. Part of why I'm not gonna break it is because I think it would be very heroic to try to break it, in the sense of parents may value the race of their peers, but there's so many unobservables that are also there. I mean, when you go and read newspaper articles, people talk about, I don't know, feeling less represented or more represented, or more welcome or less welcome. And maybe the race of the teachers matters as well. And maybe the race of the principal matters as well. But maybe it's not a matter of race. Maybe there's also some unobservable in these principals or teachers or students that are more amicable to other races and less to, I don't know. So there's so many unobservables here that I think teasing out the effect of the race of the peers can be a little bit heroic, at least with the data I have right now. Yeah. Okay, so having said that, let me talk a little bit about the assumptions that I'm gonna be making when I estimate this model. So the first assumption that I'm gonna be making is that parents rank all acceptable schools in preference order. An acceptable school would be a school that I prefer to being unassigned. So in the worst case, or I don't know if worst case, but in one scenario is that I'm just unassigned to anything. There's not enough spots, I won't get anything. So whatever I prefer to not getting assigned is going to be all the set of acceptable schools, and I should be ranking all of those in preference order. Assumption 2 says that parents are going to consider all schools in their choices. So what does this mean? It means that parents are able to get some information about the 25 schools that they have around. Basically, they are able to consider those 25 schools and decide which of those they want to rank and which they cannot. Assumptions 1 and 2 are motivated in a couple of things. The first one, the fact that the algorithm is strategy-proof, the fact that there are no limits to the length of lists. And in assumption 2 also, it's motivated by the fact that there's SON 2020, another context, but that studies choice in New York. He builds a model where he allows for parents to have limited consideration. So maybe some parents are not aware of some schools. They cannot really take information about all of the schools because there are too many. In his context, this is New York City high school. And I think in his context, every family can choose out of 450 schools or something like that. So a big number. And he finds that families on average can consider about 65 options. Again, in my context, families have about 25. So it seems reasonable that perhaps this is still within their consideration set. So that motivates assumptions 1 and 2. Now, assumption 3 is quite important as well. And I'm going to be assuming that Dij, distance, is conditionally independent on epsilon. So, and this is true for each covariate cell. So this basically means that, I mean, we know that residences are not randomly assigned. People choose where to live. And perhaps they choose where to live in part because they want to be close to a specific school, right? And that could be problematic for our estimation. So basically what I'm going to be assuming is that whatever drivers of sorting into a specific neighborhood that are correlated with preferences for schools, any of those forces are already captured by delta and L. So delta, again, remember, is some sort of school fixed effect. So it should embed both observable and unobservable school characteristics. This is still an assumption, of course. And let me talk about a little bit more about that assumption in a minute, but basically that is the assumption I will be making. So let me talk very briefly about assumptions 1 and 2, 1 second. So basically, given those assumptions, basically how would I map the model to the data given those assumptions? Well, it would mean basically that if Ri is the ranking that a family submitted, I know that this guy is the one that maximizes the utility among every other thing in the choice set. And I know that the kth option, so Rik, is going to be the guy that maximizes the utility among the remaining unranked choices, etc. And it also means that whatever thing that I ranked, whatever object that I ranked should be preferred to the outside option that I'm going to normalize to 0. And the outside option should dominate anything that I didn't rank. And both of these things are consequences of assumptions 1 and 2 that I'm going to use to estimate the model. Any questions there? Okay. So let me talk a little bit about assumption 3 that I think is quite important. So let me reiterate in what I was saying. So the problem here is that the identification problem here is that I want to really understand what's the impact of distance. So how do families value distance? And when I see a family that's ranking a school that's very close to their home in their first position, I can conclude 2 things. I can say, oh, maybe that family values a lot distance. I mean, or better, they value a lot proximity. For them, distance is very costly. So that is why they're ranking this school that's very close to their homes. But alternatively, it could also be that they really like the school. So they decided to move very close to the school, and that's what they're ranking. So when I see someone ranking something very close, is it because they dislike this traveling, or is it because they really like the school? It's kind of an identification problem here. So again, my assumption is going to be that whatever drives people to live in a certain place, I'm being able to capture it with the delta. But of course, this is still an assumption. So a way to kind of evaluate how prominent sorting is in my setting is using the discontinuities generated by the algorithm. So in the left here, I'm showing you, or before I go there actually. So let me remind you that the algorithm says that if you live closer to a mile from a school, you have a higher priority, right? So then you should have a higher probability of getting assigned to a school if you live closer to a mile, right? To kind of see that in action, to try and see that in numbers, here I'm plotting in the left all the pairs, every student and their first choices. I'm taking all of that data, every student and their first choices. I have in the x-axis the distance to the proximity boundary of that first choice. So 0 here means that I live exactly 1 mile from that first choice, that first school that I ranked. So the proximity boundary is a mile from the school, right? To the left are students that live closer to a mile from their first ranked school, -1 being they live right there in the next building of the school, if you want. And to the right is students that live farther than a mile from their first ranked school, okay? And here in the y-axis, what I'm plotting is the probability of getting assigned to that thing that you ranked first. And what we see here is a sharp discontinuity. It means that if you live within the proximity boundary, so within the mile of a school, and you rank that school first, you have a higher probability of being assigned to that school than if you rank that school first, but you live farther than a mile. So there's really a discontinuity. This means that it is better for a family to, if I'm gonna sort, if I really like a school and I wanna maximize my chances of getting into that school and travel little, I benefit from moving 0.9 miles of that school versus 1.1, because 0.9 guarantees me a higher probability of admission, whereas 1.1 doesn't, okay? So again, this means that if families are sorting, we should be seeing to the left of the boundary, the families that really like these schools, the families that really, that think that that school is really, really great. So to try and test that, here I'm taking the same x-axis, and now I'm taking all of the pairs of schools, student and schools, and I'm saying, okay, what is the probability that someone ranks first a school that is very, like 0 miles from their home? This would be -1, right? Because we're right there at the school. The 0 here is again being 1 mile from the school. So again, the probability of ranking first the school that is at that distance. And what I find is that there's no discontinuity here. How do we find out discontinuity? What does that mean? It basically means that the people that live to the left are the people that really value those schools, because are the people that are really eager to rank it first. Not finding a discontinuity doesn't mean that there's no sorting, to be very clear. But having a discontinuity would be coincident with sorting, okay? So I don't want to rule out that sorting exists. This is not ruling out that sorting exists. It's just saying it's not very clear that there's I mean, at least this is not consistent with a very strong sorting. That's what I want to say. Here I'm plotting this using only the schools that have high excess demand, so the very popular schools. But I can do this also using all students. And again, we don't see any discontinuities. I can do this only using Black students. I can do it using only Hispanic students, and I can do it only using white students. And in any of these cases, we see a very clear evidence of that. So just to reiterate, this doesn't mean, this is not a proof that sorting doesn't exist. This is just at least telling us that it doesn't seem to be super salient. Because had we seen a discontinuity, it would be in line with sorting. So basically, I'm gonna make the assumption again, assumption 3, and I'm gonna make it throughout the paper. So I estimate my model, and here I'm showing you, I estimate the deltas, if you remember. Here I'm showing you what would happen if I map those deltas into school characteristics. So what I was basically mentioning earlier to Laura. We can take those deltas, which are black boxes, right? There's a bunch of things there, amenities and disamenities, and we can try and see, are these things correlated with some school characteristics or not? And well, when we do an individual regression of these deltas with each of these school characteristics, we find that all of these things are highly correlated. When we put all of these characteristics in one single regression, we lose a lot of statistical significance. Some things survive, some things don't. I think it's important that say, well, school achievement, or the fraction of students that are proficient in math, which is our measure of school achievement, is positively correlated with delta. So families value schools that are higher achieving. This is not very statistically significant. And most of the statistics, but let me remind you that if you run just the simple correlation, it is very significant. It's just that we are putting a ton of things together. When you throw in there racial characteristics, those are the ones that typically absorb the significance. So, and they're also interesting in that we see some heterogeneity. So cluster 1 and 2 are Black students. And we see that Black students value being around other Black students, but there are kind of some negative returns to it. So this relationship is not linear. So this is the squared of the fraction of Black, and this is the fraction of Black, right? Now, if we go and look into the clusters 3 and 4, these are Hispanic students, we see that their deltas at least are negatively correlated with a fraction of Black. So most of them wouldn't want to be in schools, according to this, with schools that have high fraction of Black. For instance, the fraction of white is positive along, so it seems like everyone would find this like an amenity, and it is significant for everyone, so it's important. But again, there are some diminishing returns to it. So this is all to say that things map back into school characteristics in a way that seems reasonable, and the demographics seem to be absorbing more of the variation, at least among these characteristics, which means that these are very salient for parents, but also that they are drivers of preference heterogeneity. So with that, let me jump into the counterfactuals. And I think we have 20 minutes left, more or less. Okay, so what am I going to do with the counterfactuals? So I'm going to take the universe of schools and students in the year 2011, and I'm going to generate 3 types of counterfactuals. The first one is that I want to change the residential location of one minority student at random. And the idea here, the thought experiment, is imagine that I have a minority student, let's say a Hispanic student, and I want to see, well, what would happen if this student lived in the residence of, or a typical residential location of a white student. I'm not going to change the preference parameters. I'm not going to change anything else. I'm just going to say, let's move this student from location A to location B, and let's see how are the rankings of this student and the subsequent assignments going to look like. What I'm going to do really to operationalize this whole thing is I'm going to randomly assign each minority student in my sample with a new residential location that I'm going to draw from the distribution of white students' residential locations, okay? And after I assign to each minority student a new residential location, I'm going to generate again the rankings, and I'm going to generate again the assignments by running the DA. But importantly, I'm only going to do this one student at a time. I'm not going to change the residential location of everyone at the same time. And the main reason for that is that I want to sustain the assumption that the preferences for schools are unchanged. If I change people around, I still want to use my model to predict their rankings, so I cannot do some change that I think will alter those preferences. And if I change everyone, I change the residential location of everyone, the demographics at schools will likely change, and other things that we think are very relevant for the preferences of parents. So in the spirit of not changing, kind of doing a measure zero type of change, we're only going to change one student at a time. So that's the first counterfactual that I'm going to do. The second counterfactual is, instead of changing the location, I'm going to be thinking of changing the demand parameters. So again, I take one minority student, and I'm not going to be thinking of changing the location, but I'm going to say, okay, in this location where he lives, what would happen if we change the demand parameters, the parameters we estimated of that student, and change those for those of white families? In that case, I want to see, it would help me identify the drivers that are explained more from the preference side that is independent of the distance, although I'm going to talk more about that, that will come from the first counterfactual. And the third,
and the second one is, I'm not going to change location.
Mm-hmm.
I'm going to change the beta and the delta.
That's right. And
I'm going to take the ones from the cluster number 1. I'm going to put them in cluster number 5, something like that. Okay.
So I'm going to preserve incomes, and I'm just going to change race. So to the blacks, I'm going to give whites. To the Hispanics, I'm going to give them the whites, but I'm going to preserve the income side.
Same income. Okay.
Excellent. Good. That's what I'm going to do. Thank you. Thanks for the clarification. Perfect. And finally, in the third one, what I'm going to do, this is way more, these two are a little bit easier in the sense that I'm basically just going to eliminate proximity priorities and reassign, or eliminate choice menu restrictions, then see how would people rank schools if they didn't have any choice menu restrictions. They could choose from wherever they want, generate rankings, and then assignments. So that's going to be the last one, eliminate either of these rules. Now, let me say something about the connection between counterfactual 1 and counterfactual 3. Notice that when I change the residential location of a student, I move a student from location A to location B, I'm changing two things. The first thing I'm changing is the menu of distances. So these students are going to be closer to some schools and farther from others. The second thing I'm changing is the fact that that student that moved perhaps is now choosing schools in a different choice menu, and perhaps has a different set of schools with a proximity priority. So I'm really moving two things: the rules, the rule part, the rule component of this, right? And the distance component of this. I really want to learn about the distance alone. I don't want to learn about distance bundled with the rules. But that's where counterfactual 3 comes in. If I take the results from counterfactual 1 and I take the results from counterfactual 3, both of them will help me learn something about the distance. Because again, this one is distance plus rules, and this one is only rules. So kind of both of them help me identify really the effect of distance alone. And I'm going to be more clear about it in 1 second, but that's the main idea. The first one is the bundled treatment. Changing residential locations is a bundled treatment of changing menus of distances and changing rules. In the last one, I'm going to learn about what is the impact of rules. Hence, I'm going to learn something about distance. And finally, for each of these counterfactuals, I'm going to recover the whole distribution of school achievement for students in each group, for Black, White, and Hispanic students. So let me show you the results. Oh, but first, there's another thing I need to tell you. There's a slight complication that I need to be mindful of. Well, a set of my students, Black and Hispanic students, have sibling priorities where they live. They live in location A, and their sibling is in school, whatever that is close to their location A. Now, how do I handle their sibling priority when I move them? I need to be kind of careful about that, right? And one can do a wealth of things. So the first thing I'm going to do is I'm going to say, okay, I'm going to move this guy from location A to location B, and I'm going to say that he or she is going to lose any sibling priority that they had. This would be consistent with the idea that maybe the whole family moved and both of the siblings need to search for new schools in the new location. Now, notice that this really, really harms minority students in the following sense. With certainty, none of the students that move are going to have a sibling priority, but with certainty, there's a subset of students in that new location that do have a sibling priority, meaning that these students that move, my treated students, quote unquote, are always in a lower priority group, right? So that harms them a little bit. So I want to think of more things. So the second thing I try is say, okay, let's say that they keep their sibling priority in their old school, wherever their older sibling went. And what I find is that actually the results from both of these counterfactuals are almost identical, because, well, having a sibling priority very far is almost the same as not having a sibling priority at all. So I'm not even going to show you results on counterfactual 2. I'm only going to show results on counterfactual 1. Now we can be a little bit more creative. So in the third counterfactual, what I do is I predict what would have been the most likely place where the older sibling would have been assigned had the family moved to the new location when the older sibling was choosing schools. How do I do that? I use the parameters of the model for that. I'm not going to describe the details here, but I'm happy to talk about them offline. But basically, I do a prediction of what would be the most likely school that someone would have a sibling priority when they move in the new location, of course. And I'm going to show you some results on that. And then the last assumption that I do is, okay, what if in the new location, the students that had a sibling before and moved are going to have a sibling in the first school they run, in their favorite school. So this is kind of the extreme where I'm really favoring them a lot, right? And this would be kind of an extreme case where the older sibling was always assigned to the first choice or something like that. I'm going to discuss the results in a minute, but just to give you a preview, I do not find that these are too different from each other, which is good because I think none of these are in itself very credible. Like they all seem a little bit crazy individually. But the fact that they do not give us very different results, it's good in the sense that they tell us, okay, our effects are really bounded here, and they don't really depend on what you assume about siblings, okay? So again, I'm going to show you results for 1, 3, and 4. So let's start with 1. So here I'm showing you the initial distribution, the cumulative distribution of school achievement for Black and Hispanic. So for Black and white in the left and Hispanic and white in the right, these are the original distributions. So again, you see the gap and the dominance, the stochastic dominance. When we relocate Black students in the left and Hispanic students on the right, what we see is a shift to the right in that cumulative distribution for both groups. And this accounts for a reduction in the gap of 49% for Black and 47% for Hispanic. Again, this is assuming that people lose any sibling priority. So this is important because, again, these students are we're harming them, quote unquote, in the sense that they are really below the priority list in most of the times. But even with that, the gap shrinks by almost 50%. So this means that, well, relocation is pretty salient, even if we ignore the sibling priority. Now, what if, let's go to 3. I said that 2 is almost the same, so I'm not going to show you. 3, we're going to predict the sibling where the students would have had a sibling in the new location. And that increases this gap, the reduction in the gap from 49 and 47 to 53 and 49. So you see that it's not a huge change. So location without a sibling and location with a predicted sibling both kind of reduce the gap about 50%. For counterfactual, we're just going to give them the sibling priority in the first choice school. So we're really helping them in some way. And what this means is that the gap is going to, the reduction in the gap again is going to go from 53 and 49 to 57 and 54. So again, not huge change. So basically everything is very much bounded about around 50%. And our preferred specification is actually going to be T3, treatment 3, which is where we predict where the siblings will be. So again, location matters, and it explains about 50% of the gap. Let me jump into preferences. So we're going to change the preference parameters of families, as I explained earlier. And what we find when we do that is a reduction in the gap of about 41% for Black students and 29% for Hispanic students. So it's still salient, but less than what happens, what location explains. And now, as I said, location is really bundled. It's a bundled measure of, when I do the location counterfactual is kind of a bundled treatment, quote unquote, that includes both the change in the menu of distances and whatever effect of the rules there is, right? So to disentangle this, I'm just gonna go and see, okay, what would happen if you just change the assignment rules? The first thing we're gonna change is choice menus. So here's what I'm showing you in the left. So basically what I did there is I'm gonna say, we have some preference parameters and I'm gonna allow people to choose from any school across the city, not only the schools in these bounded zones that I showed you in the map earlier, but they can choose the school very far away. They can choose the same school that they chose in the location counterfactual if they want it. It's not a restriction. They could. So basically the only reason why the Black students here are not choosing that very same school is the distance, right? Because it's allowed. And what I find is that when I do this, you see that both of these distributions look very similar to one another. The effect is not really zero, but it's very, very close to zero, close enough that it's not really that important. So again, it's not zero. In the paper, I showed the numbers, but it's very close to zero. This is what happens with choice menu restrictions. And then when we eliminate proximity priorities, this is really even a simpler counterfactual in the sense that people are not even changing their rankings, right? So priorities do not change rankings. I just use the same rankings and I just write priorities in a different way and I reassign, and again, almost nothing changes. So this means, you know what, rules, don't really have an impact. So that 50% that we saw earlier that was explained via the location counterfactual is really the effect of distance, is the fact that those students are now closer to certain schools and farther from others. But it's not explained because the choice menus are different. It's not explained by all of those things. It's the impact of distance on their assignments. And here's just a very quick kind of summary of all the numbers that I just showed you. So let me walk you through it. For the
Mariana, perdón, te quedan como 10 minutos. Sorry.
Oh, I think I'm gonna finish a little bit earlier, but yeah, we'll have more time to chat, I guess. Pero gracias. So yeah, let me give you kind of a summary of the numbers that I just showed you. I showed you a ton of things. So the preference counterfactual that I showed you, for Hispanic students, it implied a reduction of the gap in 30%, 29 exactly, but let's say 30. And for Black students, it was 41, okay? Now, for location, I showed you 3 counterfactuals. I show you 1, 3, and 4. Location 1 implied a reduction of about 50%, a little bit less than 50%. This was the one when we assumed that they lost any sibling priorities. Location 2 was when we said, okay, maybe they keep their old sibling priority, so in the old school that they had before, which may be far from their new locations, but we're going to keep it. You see that these things are almost identical. Location 3 I showed you, and I said, okay, this is when we predict the sibling location, and the reduction is a little bit more than 50 for Black, a little bit less than 50 for Hispanic, and then we went all to the right to the case when I assume that their siblings are that they have a sibling priority in their first rank school, so whatever they prefer. And here it goes a little bit above 50, but just mildly. So in general, the location effect is very much concentrated about 50. And again, this is our preferred specification, while the preferences explain a little bit less than that. Still important especially for Black families. So with that, let me conclude and we can have a discussion. In this paper, I discuss how, among other objectives, school choice are sought for their potential to equalize access to high quality education and desegregate schools, among, again, other objectives. Now, I showed you that despite these, we see differences in the access to higher achieving schools for students of different races in Boston. And well, what I find is that this is mainly explained, or the mechanism that explains this, or that has the most contribution to explaining this, is the fact that minority students tend to live farther from high achieving schools, and that impacts their demand for these schools. we also saw that demand for other attributes that are independent of distance do matter. And this perhaps has to do with preferences for race in their peers, and a wealth of things that are probably correlated with those as well. Cultural things, ways of wanting, I don't know, to discipline your kids. Those things tend to be, I guess, also cultural, etc., etc. Nevertheless, we do not really unpack that. We're just going to call that other heterogeneity in preferences that are not location specific. So I guess that the main takeaway for me is that choice systems should not discourage efforts to equate or search for a more equal distribution of quality or school quality in space, right? So we cannot think that school choice will solve the problem of equalizing quality. We already kind of knew that from other papers as well. But definitely the efforts to improve the quality of schools in specific areas and implementing choice are more complements than they are substitutes. Both of these policies can really help, and none of them well, I don't know if none, but in isolation, they're less effective. And with this, I don't want to say, or I don't want to claim that school choice, that school districts aren't doing this. I think that they are very much aware that choice systems alone are not going to solve the quality problem in general. It's just a really hard problem to solve in general, I think. So I do not want to, just claim that they are not. I think they are very aware of this, and they work towards these goals. But just as academics, I think is worth highlighting the fact that these two policy objectives are not exactly the same, and these policy tools are not exactly the same. And yeah, that's all.
Bueno, pues muchas gracias, Mariana.
Gracias a ustedes.
No sé si alguien tiene alguna pregunta, es el espacio para empezar una discusión y quizá preguntas.
Yo, nada más un comentario, soy Laura. ¿Sí me escuchan?
Sí, te escucho.
Ya, gracias. Me parece muy importante el mensaje que acabas de dar sobre lo del policy, porque yo creo que sí, bueno, parece que hay evidencia de que es muy importante, sobre todo para las minorías, pues las preferencias sobre la composición racial, ¿no? De las escuelas y también a lo mejor de sus barrios, que es lo que hemos estado discutiendo. Edwin te preguntó sobre eso, ¿no? Como que a la gente, sobre todo a la que enfrenta cierta discriminación, pues tiene preferencias muy altas por estar con gente similar a ella, ¿no? O no se siente cómodo estando con gente diferente. Entonces, pues sí, en un mundo así, pues lo de por sí solo lo del school choice, pues es limitado, ¿no?
También, por supuesto.
Y ya, nada más. Muchas gracias.
Sí, no, es totalmente, sí, de acuerdo. Sí, he tenido reacciones al paper que a veces me dicen que justamente les parecería interesante hacer casi que esa cuantificación de que tanto la gente como de forma causal, reaccional a la composición racial del colegio. Es decir, así que si uno pudiera pensar en un contrafactual que si cambia la composición racial, ¿qué va a pasar? No sé todavía si ese es el camino, para ser honesto. Yo creo que la pregunta es supremamente interesante e importante. Creo que puede ser un poquito, como decía antes, heroico tratar de hacerlo, pero tal vez vale la pena pensarlo más. Gracias.
Yo tengo una pregunta, a lo mejor no lo entendí bien, pero hiciste el nivel de heterogeneidad que estás incluyendo es por raza y por ingreso, ¿no?
Sí, señor. Sí.
Y arriba, abajo en la media. ¿No te parece poca heterogeneidad en el ingreso eso?
Sí. Idealmente quisiera más. O sea, no sé si es poca. Lo que estoy de acuerdo contigo es que en el mundo ideal uno quisiera tener un poco más, o sea, acá lo tengo por ingreso arriba de la mediana o de la media, no, de la mediana, y ahí abajo de la mediana. es difícil hacerlo un poco más desagregado. Entonces traté de hacerlo con cosas más desagregadas, pero el problema es que uno es como es un trade-off que uno tiene, porque si uno lo hace muy fino, entonces empiezas a ver muy pocas personas de cierto grupo en algunos lugares geográficos, y eso también pues es perjudicial, porque entonces uno no sabe si esas personas no están rankeando sus colegios simplemente porque son muy lejos, o si es porque de verdad está revelando su preferencia, ¿sí me explico? Entonces, en el mundo ideal uno tendría un poco más, pero Boston tampoco es una ciudad muy grande, entonces la muestra no es suficientemente grande como para poderlo desagregar un poco más, desafortunadamente. Estoy de acuerdo que en el mundo ideal sería mejor tener algo un poco más desagregado.
Gracias, gracias.
Mariana, hay algunas preguntas en el chat que te voy a transmitir, ¿no? Si tú quieres leerlas, no sé.
Entonces dice, ¿el costo de inscripción es el mismo para cada escuela o está estratificado por región? No hay ningún costo de inscripción. Esto es escuelas públicas y nada, el costo es cero. Inclusive ofrecen buses, que no lo mencioné, entonces eso tal vez es importante. Inclusive hay transporte, todo es gratis. Esto es un distrito escolar, entonces en Estados Unidos la forma, digamos, de dividir las responsabilidades educativas es por distritos escolares, y un distrito escolar se encarga de educar a toda la población de ese distrito escolar. Los ingresos, que usualmente son por impuestos a las viviendas, a la propiedad raíz, son también de ese mismo distrito. Entonces, todos los residentes se recoge el ingreso por vía de esos impuestos en esa misma región, con esos mismos límites geográficos, y se distribuye equitativamente, es decir, no hay unas reglas de distribución de esos recursos por estudiante que tratan de ser equitativas. Obviamente hay unas discusiones al respecto de qué tan equitativas lo logran ser al final, pero más o menos así es como funciona. Entonces, de nuevo, la siguiente pregunta dice, ¿hay diferencias en el costo de las escuelas más prestigiosas? No, no hay ningún costo. Todas estas son públicas, no hay ninguna diferencia en el costo. Que sea alguna estimación del porcentaje de padres y madres que trabajan, habría la posibilidad de calcular un efecto adicional de la distancia que tenga que ver con la distancia entre la escuela y el trabajo de los padres. Eso es súper interesante. No tengo, yo asumo que no en el censo, tal vez podría ser alguna estimación del porcentaje de madres y padres que trabajan en algunos demográficos, probablemente a nivel de el census tract y con algunas características observables. Sin embargo, lo que me parece más interesante sería si uno pudiera ver el lugar de trabajo de los papás y tener eso también en cuenta, porque creo que es bastante importante. Traté de conseguir datos de esto, pero no son fáciles de conseguir. Ciertamente el distrito escolar no los tiene. Sí, entonces no, desafortunadamente no se puede hacer nada por ese lado, por lo menos en este setting. Habría que ver si hay otros lugares donde se puede. Interesante. Gracias por la pregunta.
¿Alguna otra pregunta?
Creo que hay uno. Bueno, muchas gracias. Perfecto.
Bueno, pues yo sí tengo 1000 preguntas, pero pues podemos platicar luego.
Bueno, como quieras.
No, súper interesante. Muchísimas gracias, Mariana. Yo creo que si no hay más preguntas ya podemos como terminar la transmisión en vivo, la grabación. Y muchas gracias a todos por conectarse. Pues muchas gracias a Mariana por acompañarnos, por presentarnos esta súper interesante y relevante investigación. Pues bueno, muchas gracias.
No,
de veras.
a ustedes
Muchas gracias. Muchas gracias. Hasta luego.
Gracias, Mariana. Muy interesante.